first thing we need to do here is realize that in order to work out the average speed is going to be the total distance traveled. Okay, well that's easy enough. That's just 38.5 kilometers. Okay, and then you divide that by the total time taken. So the total time taken. Now, problem here is that they're asking us to find the average speed of the train in kilometers per hour, but they give us the distance in kilometers. That's fine. They give us the time though in minutes. And what you have to realize here is that 21 minutes is actually just a fraction of an hour. It's actually 21/60ths of an hour, and you can change that into a decimal by just using your calculator, dividing 21 by 60. You get 0.35 hours. Okay, so if we now divide 38.5, which is kilometers, okay, you don't really need the units there, just to help you, by 0.35, and the 0.35 is in hours. Now that gives us, using your calculator, 110. That 110, because you're dividing kilometers by hours, gives us the speed in kilometers per hour, in this case the average speed in kilometers per hour. Okay, right, if we scroll down to part B, okay, what we've got here is a tunnel, and the tunnel is a cylindrical hole 38.5 kilometers long. I sometimes find it helps to draw a diagram here. So we've got a radius there of 4.19 meters. Okay, the length of the tunnel though, okay, it's a really long tunnel, okay, is going to be 38.5 kilometers. Now the problem here is we've got a mixture of units, so let's change the 38.5 kilometers. We know that 1,000 meters is the same as a kilometer, so that's going to be 38,500. Yes, don't need that. 38,500 meters. Okay, now if you look in the formula book at the front of your exam paper, it tells us that the volume of the cylinder is pi r squared h, where the radius is r and the height is h. In other words, in this case, the volume of the Earth, and we've got everything in meters, so it should work out, is going to be pi times the radius squared, well that's times 4.19 squared, multiplied by the 38,500. Now if you work that out, it comes out as, my calculator, 212,3433,3433, so 2,123,433.419 cubic meters. Now we've got to round that to 3 significant figures, which basically means we're going to chop off after the first 3 digits. What we've got to be careful of though is that we fill in these remaining places with zeros, otherwise well, clearly it would be ridiculous to have an answer of 212 cubic meters when this is actually 2,123,433, etc. So basically we're going to write 212 and then 0000. We don't need to worry about the numbers after the decimal point. In other words, the volume of Earth removed is 2,120,000 cubic meters to 3 significant figures.